All right, so today we're solving Leetcode problem 456. This is called 132 pattern. And yeah, one more thing. This is a logged problem. So if you don't have a premium Leetcode subscription, you probably won't see this. So what I'm going to do is I'm going to copy this problem in the description so you can read it, or you can just pause the video and read it. All right, so let's dive in. So this problem asks you to find a pattern. So you have been given an array, and then you have been asked to find a pattern where, let's say, I, j, and k are indices of this array, and they are increasing, right? So you have to find three numbers where a of j is the maximum. So a of j is greater than a of I, and a of j is greater than a of k, meaning a of j is the greatest element of all three. And the third element, a of k is greater than a of I, and it is smaller than the middle element, which is a of j, right? And a of I is the smallest element. So if such a pattern exists, you have to return true, or otherwise you return false, right? And this I, j, and k are not necessarily contiguous, right? So j is not equal to I plus 1. It may be, but it's not necessarily I plus 1, and k is not necessarily I plus 2 all the time. Otherwise, the problem would have been very easy, right? So yeah. So how you approach this problem, the easiest way is to just use the brute force method and try to find every combination of three numbers, and then you can do that. The other way is to think about I and j. So for example, if I take this array, let me get rid of this. So so at any point, if I think about, so let's say I'm iterating over this array, and how do I make sure that this 4 is a candidate for I, j, and k? So if I know that there is a number which is smaller than my current number, and then I know that there is a number in the future which is smaller than the middle element but greater than the lowest element, which is I, then I know that at that point I'm good, right? So just to reiterate what I said. So let's say I, j, and k are our numbers, right? Our indices. So if I know that, so if I can split this combination into finding out, is there a good combination for I and j? And if there is a good combination for I and j, uh, is there a good is there a good number for k which satisfies this I and j condition as well? So if I can create an auxiliary array which keeps the minimum value to certain point, and when I'm iterating over the original array, I can say that I and j conditions are satisfied, or in other words, I do have an element which is smaller than the current element. Now the only thing left to do is to find out if the k condition satisfies, right? So if I create an auxiliary array which contains the minimum element up to that index, so for example, this becomes 4, right? So now I'm iterating over the original array, and at this point 4, and I'm continuously comparing the original array with the aux array, right? And at this point, I find that, okay, I've reached a position where j and I conditions are met. Now, the only thing to check is k condition. And the way you can do that is you need to keep track of all the numbers which are greater than I, but also less than j, right? Because if you remember the initial condition, a of j is the greatest element, and a of k is greater than a of I, but smaller than a of j, right? So it may seem confusing, and it may be in the beginning, but once you read the code and figure out, it's pretty simple. All right. So I'm just gonna get into that. Oh, and yeah, and always make sure you check the null conditions. They have tricky test cases. And since we do need to find, so we do need at least three numbers, right? So we can just say if we don't have three numbers, we can just return false. So I'm going to use a stack, and I'll tell you in a bit how we can use the stack. And then I'm going to create my auxiliary array, and this array will keep the minimum element to that certain index. All right, and then I'm going to iterate over the original array. And actually, I can do this. I can start from 1, and then at the 0th index, it is the first element, right? Because you have nothing to compare. And then this becomes okay. So what I'm doing here is I'm just making sure that at a certain index, I always have the minimum value. So I'm comparing the current element in the original array with whatever I have uh, in the auxiliary array. So if there's a smaller value, then auxiliary k would get the smaller value, and in the next iteration, we'll compare it again. All right. So what my plan is to, as I said earlier, I'm going to keep comparing the auxiliary array with the original array to find a pair of I and j. And then I'm using this stack for the values of k. And you want to put values in the stack which are eligible for this pattern, right? So what I mean by that is, so if I start from the end and and whenever I see a j, whenever I see that I and j has been found, then I push that value to the stack. And at any certain point, I only have to maintain values which are eligible in the stack. So when I say eligible, the values which are uh, greater than the smallest element, a of I, but less than the middle element, a of j. So actually, you can push the last element in the stack anyway, and then we can start iterating from the second last element. So I'm just putting the last element, and then you can start iterating from the second last element here. All right, so if nums of j is greater than aux of j, right? So at this point, we have found that, okay, there is an I and j pair. There is an increasing sequence so far. Then in your stack, what you want to do is only maintain elements which are greater than aux of j, and because you don't know, because you do know the minimum value of the array at that point, right? So there's no point in storing values less than aux of j, because for this condition to satisfy, the k aux the nums k has to be greater than aux of j. So I'm gonna say while stack is not empty, and stack dot peak. So I'm gonna keep popping until I get a value which is greater than aux of j. So if I get anything which is less than or equal to aux of j, um, I pop, right? And at this point, if your stack is not empty, then you probably have an, not probably, you obviously have an element which is greater than aux of j. So now the only condition left is checking with the middle element, right? And it has to be greater than the middle element. And middle element is nums of j. Okay, so if this condition is satisfied, you return true. Okay, and there we go. And then you want to push to the stack. And then you can return false in the big end. Okay, looks like we missed something. So I think what is happening is if nums of j is greater than aux of j, we have found the ij combination, and then well, stack is not empty, and it is as long as it's greater than aux of j, we have to pop, and then stack is not empty, and it is less than, it has to be less than the middle element. All right. Well, all right. So I think we could improve this a little bit, but this was it. Thank you for watching, and please let me know any future questions you want me to go through or anything else. Thank you for watching, and I'll see you in the next one. Bye.